to bring us home for our session on Food Talk, I'd like to introduce a colleague within the department, Dr. Laura Schmitt Olabisi. He's an associate professor in the Department of Community Sustainability and the Environmental Science and Policy program at MSU. She will be our last presenter. And again, I hope many of you on the Zoom audience have stayed around to learn more about how the food system is like a cake. Laura, come on up.
Okay, so I realized that perhaps titling this talk this way was a bit misleading since we don't have actual cake in the room today. So I apologize for that. But I want to start out by posing the question, what is a food system? We talk a lot about a food system, but what do we mean when we say that? So I pulled a couple of definitions. From the Oxford Martin Program on the Future of Food, a food system is, quote, all those activities involving the production, processing, transport, and consumption of food, including the governance and economics of food production, its sustainability, the degree to which we waste food, and how food production affects the natural environment. And then Wikipedia describes a food system as all processes and infrastructure involved in feeding a population, growing, harvesting, processing, packaging, transporting, marketing, consumption, and disposal of food and food-related items. So I'm a systems ecologist, which means that I don't have a background in food. I'm trained in the study of complex systems that have human and natural components. And I spent my now 16-year career studying complex systems. And to me, these definitions of the food system have a couple of the characteristics of complex systems. They have components or parts, things like processing, transportation, consumption. They have connections between those parts, denoted by the processes and activities that are part of the definition. But what they don't include, and what is a critical aspect of complex systems behavior, is the notion of emergent behavior. So what is emergent behavior? Well, it is behavior that cannot be predicted by looking at the system's components in isolation. So one metaphor that I often use for emergent behavior is the metaphor of a cake. So if you were going to bake a cake and you had all of the ingredients set out on the counter in front of you, and you tasted each of those ingredients in isolation, so you tasted the sugar, the flour, the butter, the eggs, none of that would give you any idea of what the final cake would taste like, right? The taste of the cake emerges from the interactions between those components in the heat of the oven. So the taste comes through those interactions, it emerges. And emergent behavior is a very important concept in complexity and complex systems. And I would argue that food systems fall into that category of complex systems. Yet, I don't see a lot of discussion of emergent behavior in the food systems literature or in discussions around the food systems. So why is this important? Well, again, I would argue that we can't really analyze or seek to transform food systems if we don't understand how they behave. And if emergent behavior is a key component of that, we need to be using certain kinds of systems analysis tools to get at analyzing and transforming a food system. So emergent behavior can take many different forms. In fact, in systems theory and systems science, there are certain well-known, we call them systems archetypes, which are certain system structures that produce certain types of behavior. And in complex systems theory, the behavior of a system emerges from its structure. This is a critical concept that's important to keep in mind. So I'll talk more about that in a minute. I want to go into some specific examples of emergent behavior in food systems that are kind of related to the work that I do. So one example of emergent behavior that systems often display is nonlinear change. And so roughly what this means is that what happened in the past is not a good indicator of what is going to happen in the future. So the rate of change that you saw in the past is not the same as the rate of change going into the future. And often what this is called exponential or runaway growth that accelerates year upon year. So while this type of growth is common in systems that are dominated by humans, like food systems, because the human population is growing exponentially and a lot of our demands for food and our impacts are also growing exponentially, people in general, and by that I mean all people, Homo sapiens, tend to be pretty bad at thinking in terms of nonlinear change. We tend to think very linearly. So an example, recently I was in Nigeria. I was facilitating a workshop for poultry sector stakeholders, asking them what concerns they had for their industry in the face of climate change. And one of the activities I had them do, I had them draw on a graph the trajectory of the poultry sector in Nigeria to show us what it's going to look like going into the future. And some of them drew the number of birds, some of them drew the number of poultry operations, some of them drew the dollar value or naira value of the poultry sector. But if you notice, this is a typical chart. All of them drew that growth as linear, as changing constantly. However, I know from my colleague, Dr. Suwaida Liverpool-Tazia's work in AFRI here, that the poultry sector in Nigeria is not changing linearly. It's actually changing in an exponential way. So even though these poultry sector stakeholders were highly knowledgeable, they didn't perceive that from theirs sitting within the system. And this is not to pick on poultry farmers in Nigeria. People have done this type of experiment with all kinds of folks, including graduate students at MIT, and just everybody is generally pretty bad at understanding exponential growth and nonlinear growth. Another common systems archetype is the, quote, success to the successful archetype. And I would argue that this can help us understand food deserts. So the notion of success to the successful is if you have a lot of resources, you have the means to garner even more resources for yourself and to outcompete those with fewer resources. The corollary is that if you don't have a lot of resources, you are fundamentally unable to get more for yourself. So the corollary is kind of the poverty trap that economists often refer to. So if you are a wealthy neighborhood, for example, and you have a high property value, a lot of disposable income, you're probably going to be better at attracting businesses and food retailers. Whereas if you're a poorer neighborhood, you are not going to do so well at attracting those folks. And so you're not going to get the add-on economic benefits and gains that might come from having, say, a grocery store in your neighborhood. So in a sense, the rich get richer and the poor get poorer, and you have this kind of divergent outcomes. And I think you do see that in some cities. So once you train yourself to look for systems behavior, I would argue that you can really see it everywhere. And you can also kind of see how a lack of systems thinking can hamper us in finding solutions. A lot of times, particularly in the United States, when we see a problem, we want to look for one person or one institution or one cause to blame. But in systems theory, we know that that is rarely the case, that there's one entity to blame, because again, the behavior emerges from the structure of the system. It does not emerge from just one person or one interaction. And so you can have systems that are rife with unanticipated consequences that no one really intended, but that we don't want. So how do we become better systems thinkers? How do we find the root causes of problems so that we can move food systems more towards sustainability and healthy outcomes? Well, I would argue that one way is by using explicitly systems science research methods. One example is the technique that I use, system dynamics modeling. And you can use this in collaboration with community members and stakeholders. So this is a diagram of the food system in Detroit that Detroit stakeholders drew. And I can then take this diagram and put numbers on it and simulate it in a computer simulation so that we can look at how the system changes over time and look at how interventions might affect that trajectory. But if you're not a modeler, there are other ways that you can become more of a systems thinker. And I would encourage anyone who's interested to go to this website put up by the Waters Foundation, where they showcase 14 different habits of a systems thinker and ways that you can become more of a systems thinker. We talked about two of these ways here. We talked about how elements within the systems change over time, and they generate patterns and trends. So simply understanding that is a good kind of step further to being a systems thinker, and recognizing that a system structure generates its behavior. So it's worth keeping this in mind when we talk about food systems and how to shift them towards sustainability. And kind of the takeaway here is that we need to pay attention not just to the components of the system and not just to the connections between those components, but to how the structure of the system generates certain behavior over time, how that emerges from those interactions. That's where I'll close for today.
We've got at least one question from the Q&A on Zoom, but we'll start with this question, Laura, if you could read that, and then we'll get to the second question. Take your time. We're actually doing well on time.
Okay, great. So the question is, how does systems analysis help us better understand how multiple food systems interventions could work together to make a real difference in communities? Right, so that's a good question. So, you know, obviously when you have a complex system, you often have multiple forces that are kind of acting on it at once. And so part of the systems analysis is understanding what the root drivers of that system are. Like what is really the most influential in changing its trajectory over time. That's one of the things we look at. So this can help us understand kind of which intervention might be most influential, or which combination of interventions might be most influential. Okay. What are some of the things you've seen work in interrupting the success to the successful impact on community food system development? Oh, okay, that's another good question. So again, the success to the successful archetype is a kind of commonly seen systems archetype, and there's kind of, I guess, prescribed ways that you can somewhat interrupt that system behavior. And one of the ways is by, this probably is not surprising, but by giving a boost to the less successful. So giving them the means to kind of compete with the successful folks and get some more of those resources for themselves. So whatever that might look like. So in the context of, boosting households out of poverty, that might be giving them access to the same resources that the more successful households have. In the context of neighborhoods competing, it might be, any number of policy interventions that could give those neighborhoods an advantage in competing for a food retailer to locate there, for example. All right, and that's it.
Okay. Laura, thank you very much.
Thank you.